Alright, people, welcome back to, I believe, the start of another week. And what I thought we would do first, real quick, is get back on track with where we left off last week and how it's going to continue into this week. Because section 5.2, we're going to, we've already spent one sort of day, so to speak. We spent one day or one assignment doing it. And we're going to keep spending, another 2 or 3 days on it. So 5.2 is about solving systems of equations. And I just want to remind you how the substitution method works. If you watched the whole video from last week from 5.2a, then you probably have a really good foundation or a good understanding about how this method works. But before I give this next assignment, which I believe would be like 5.2a homework number 2. Alright, because remember, homework number 1, I was giving you, systems of equations where both equations were already equal to y. That was homework number 1. Both equations were saying like y equals whatever. And then you could like set the equations equal to each other. Well, let's do a homework assignment. It's going to be homework number 2, where we're still going to use the substitution method, but it's not that specific scenario that you did in homework number 1. So here we go, just kind of a reminder. So let's do like 3 examples to set you up for this next homework assignment. So here we go. This system of equations has your first equation, your second equation, and you got to look at that and ask yourself, is either of those equations already solved for x or for y? And it turns out that this equation right here says that y equals 2x minus 6. So this entire 2x, I said minus, so sorry, 2x plus 6. So y equals this entire 2x plus 6. And so we're going to be able to take this entire chunk of 2x plus 6 and substitute it in and replace the y up here with that entire bubble of 2x plus 6, because they're the same, I mean, if y equals 2x plus 6, that means y and the whole quantity of 2x plus 6, they're like interchangeable. So this equation becomes 3x minus 2 times y, minus 2 times y, which is the same as 2x plus 6, equals negative 11. So that gets me going here, okay? And something else I want to point out here, like, the devil's in the details. When I move on to solve now for x, and I do the distributive property, please notice that what we're distributing here is a negative 2. So negative 2 times 2x is negative 4x, and then negative 2 times positive 6 is negative 12. And now we just kind of move on and stuff. And here's some like terms that are already on the same side. So that's going to be like negative 1x. And now I can really start to get x all by itself by moving that term out of there. And so I got negative 1x equals, let's see, negative 11 plus 12 is positive 1, and then when I divide both sides by negative 1 to finally get x fully by itself, I end up with x equals negative 1. Okay, because 1. Now, don't forget that once you solve for one of your variables, you have to solve for the other one by taking this answer and plugging it in, to either one of your equations. So I'm going to pick this one. I hope you can kind of see how that's going to be a lot less complicated. So now that I know x is negative 1, I can say that, well, then y equals 2 times, well, negative 1. And then 2 times negative 1 is negative 2, plus 6 is positive 4. So my final full answer is negative 1, comma 4. Because remember, you got to solve for x and for y. In number 2, very similar situation. But, what are we going to plug in where? Like, which equation is telling you what x or y equals? Well, it's this one. So now we know that x equals all of that. And so we're going to take that whole quantity and plug it in for x right here and completely replace it. 2 times y plus 5, and then what? Continue on. Plus y equals 1. See the substitution? We replaced the x with what it literally equals, y plus 5. Okay? And now we distribute, because now that we've done the substitution step, now we've created an equation we can actually solve. This time so it looks like this time we're solving for y first, which whatever. So after distributing, we have 2y plus 10. And now what happens next? Don't we have like terms that are already on the same side together? So 2y plus y, or 1y, that would be 3y. And now we can get y by itself. Let's move that term out of here. 1 minus 10, I believe, is negative 9. Now when we divide both sides by 3, we get negative 3. And now likewise, I think I'm going to, as far as where am I going to plug this answer in to get my x answer, I think I'm going to choose that equation. So x is going to equal y plus 5. So negative 3 we now know is y, plus 5, so x equals 2. So my final answer is that x equals 2 and y equals negative 3. And if we were going to put it together in like an ordered pair, you go x comma y, baby. I just want to do one more example because oftentimes you go to do the substitution method, but in number 1 and number 2, it was already kind of set up for you in advance, with this equation being solved for y already, and this equation already being solved for x already. But in number 3, you don't have either one of the equations that tells you from the start that x equals this or y equals that. So you're just going to have to do like a little bit of setup work. And look, you get to pick. You get to pick which equation to solve for x or to solve for y. But you want to be, you want to work smarter, not harder when it comes to that. So if I were you, I would notice that it would be pretty quick and easy and clean to get either that y by itself in this equation, or it would be just as clean and simple to get x by itself in the second equation. I'm just going to go ahead and choose this one. I'm going to get x by itself. Either way, I guess furthermore, I would not recommend getting this x by itself or getting that y by itself in the other equation, because you're probably going to end up with nasty fractions. You see how, like, to get this x by itself, all we have to do is move that term to the other side, and then mission accomplished. That's it. Now keep in mind, 5 minus 2y, you can't do. So you just leave it as 5 minus 2y. So now we know that x equals 5 minus 2y, and we can plug that in for the x in the other, remember it's got to be in the other equation. So now this equation, now that we're going to actually substitute, will become negative 3 times x, which we now know is the same as 5 minus 2y, and then the plus y, and then the equals negative 15, and now we're off and running. We can distribute the negative 3. So remember, negative 3 times positive 5 is negative 15, and then we have, look people, negative 3 times a negative 2y. That should be a positive 6y. Okay? So now, once again, we have like these like terms that are already together on one side. So that's going to become 7y. And now that that's done, we can start to get that y all by itself by getting rid of that negative 15 by adding it. So 7y is over here. And people, what's negative 15 plus 15? That's right, 0. Now, for some reason, people start to freak out at times like this, and they forget that, okay, just kind of do the next step, divide both sides by 7, and guess what? 0 divided by 7, that's 0. And it's okay to get an answer that includes y equals 0. That happens. That's allowed. Okay, you can have an answer of y equals 0. In fact, I did this on purpose in this quick little review. Anyway, now to finish this up. And people, you can even use this equation you made. You can plug into here, you can plug into here, or you can plug into here, which I'm going to do. X equals 5 minus 2 times y, which we now know is 0. So 2 times 0 is 0. 5 minus 0. X equals 5. And so our answer is 5, 0. And, your 5.2a homework number 2 should all be problems just like this.